Hello and welcome to today's video. It's going to be quite a long video today because we're covering probability and I'm going to try and cover it all in one video. So here we go. So we're going to start with some definitions. And these are ordinary English words. They're not special statistics vocabulary, but we use them all the time in statistics and in probability. First one is certain, which is an adjective. This means when you know something will definitely happen. It's sure, 100%. So for example, it is certain that the sun will come up tomorrow. Next one, probably, which is an adverb. And this is where there's more chance that something will happen than that it will not happen. So for example, I will probably eat rice today. Next one, likely. It's the same as probably. So for example, it is likely that I will eat rice today. Next one, possibly. It could happen, but it's more likely that it won't. For example, I could possibly win the computer that I bought a ticket for in the competition. Definitely not. This is the opposite of certain. You're sure 100% that something will not happen. For example, I will definitely not skip school tomorrow because we have exams. These are all words about how much chance there is that something will happen. We use these kind of words in two situations. Where there is cause and effect. For example, my mother is sick, which is the cause. So I probably won't go to school tomorrow. That's the effect. The second one is where things are random, random. That means they happen by chance. For example, my mother will probably not win the competition. So what we're going to look at this time is number 2, the random events. Notice that it can be cause and effect even if you don't know what the cause is. So the previous example said my mother is sick, which is the cause, so I probably won't go to school tomorrow. That's the effect. We don't know why your mother is sick. That doesn't make it random. Even if we know the cause was random, it is still the cause, and so it's cause and effect. For example, my mother won 1 million baht yesterday, so I'm not coming to school today. Even though it was random that your mother won 1 million baht, it is still the cause why you are not going to school today. Notice also that there is a difference between something that no one controls and something that is random. No one controls which way the wind blows, but in some countries it blows from the same direction more than half the number of days every year. So no one controls it, but it is not random. So now we're going to have a little quiz to see if you can choose which is random, which is cause and effect. Okay, first one. So someone who had a motorbike accident because a mosquito flew in his eye. Is that random or cause and effect? And the answer is cause and effect. The mosquito flew in his eye, that was the cause. Now, Mary Say won the competition where you win a computer if they pick your ticket out of a box. Random or cause and effect? And the answer is random. Nobody controls which ticket will come out. Thramu Mumupo sent a Facebook message to her friend because she heard she was sick. That one is cause and effect. She did it because her friend was sick. Throughout Plateau threw a 1 baht coin in the air 6 times. 4 were heads and 2 were tails. And the answer for that one, random. Nobody is controlling how many heads and how many tails. No, Bablupo was sick because she ate some bad pork. And that one is cause and effect. The cause was that she ate some bad pork. Now, an important idea here. These ways of calculating probabilities only work if the way the results are picked is random. So it's usually a process that doesn't include people, except to pick a number from a hat. If you use people, the ways that data can not be random can be very subtle. If I ask everybody in the class to write on a piece of paper their favorite number between 1 and 100, would that be a random method? Many people's favorite number is their birthday. So there will be more than 30% who choose a number below 30 and a bias towards those numbers. So it's not random. Another important idea. The total of all chances will always be 100%. If there are 2 names in a hat, we can calculate the chance of one of the names being selected. And then we can calculate the chance of the other name being selected. If we add all the possible results together, the answer will be 100%. In other words, one name may be picked first, or the other name may be picked first. But if you pick 2 times, it is 100% certain that both names will be picked, and the hat will be empty. If the chances are equal, like 2 names in a hat, you can get the right answer by dividing 100 by the number in the hat. So in this example, 100 divided by 2 equals 50%, or 1 divided by 2 equals a half. That is the chance. But the idea is still true if the chances are not equal. Let's say there are 4 red candies in the bag and 6 blue ones. What is the chance of picking a blue one? What is the chance of picking a red one? So the method is you put the number of blue ones on the top and the total number on the bottom, and then you multiply by 100 to make a percentage. So we have 6 blue ones, so we put 6 on the top, 10 on the bottom because that's the total, and then multiply by 100. As you can see in the picture there, you can divide top and bottom by 0, so you get 6 times 10 divided by 1, which is 60%. And for the number of red ones, so we have 4 red ones, so we had put 4 on the top, the total number 10 on the bottom, times 100. Again, we can cross out 1 0 on the top and the bottom. We have 4 times 10 divided by 1, which equals 40%. Notice how the total of all the chances, 60 plus 40 equals 100%. Now let's look at exactly the same situation, 6 red candies and 4 blue candies, but in a different way. What's the chance of picking any single candy? The color doesn't matter. So the method is you put the number of candies that you will pick on the top and the total number of candies on the bottom, and then you multiply it by 100 to make it a percentage. So you have 1 over 10 times 100. You can cross out 2 zeros, the top and the bottom there. You get 1 times 10 over 1, which equals 10%. So if there are 10 candies, every candy has a 10% chance of being picked. And the total of all the chances equals 10% multiplied by 10 equals 100%. And we can use this idea in reverse. So question, if there are 20 candies, some are red, some are blue, and some are gold, the chances of a red one being chosen are 40%. The chances of a blue one being chosen are also 40%. What are the chances of a gold one being chosen? And the answer, this is a normal minus calculation. We know the total will be 100, so we can calculate 100 minus 40, the red ones, minus 40, the blue ones, equals 20%, which will be the gold ones. We can take this one step more. What if the question had asked, how many gold ones are there? We know there are 20 candies. We know gold ones are 20%, so we can calculate how many gold ones. And this is just a normal percentage question. 20 over 100 for 20%. And the total number of candies is 20, so we multiply by 20. So we have 20 times 20 over 100. And if we cross out all the zeros, we have 2 times 2 over 1, which equals 4 gold candies. Okay, your turn. There are 50 marbles in a bag. 25 are green and 25 are red. If I pick one marble from the bag, what is the chance it will be a green one? And I'll go straight to the answer now. So what do? There are 25 green ones, so we do 25 over the total, which is 50, multiplied by 100 to get a percentage. So then we can divide 50 on the bottom into 100 on the top, so we get 1 on the bottom, 2 on the top. And then we multiply 2 times 25 equals 50%. So the answer is there's a chance of a green one is 50%. Next one. Students sold tickets for a competition to win a motorbike. One sold red tickets, one sold blue tickets, and one sold green tickets. They sold 100 tickets each. What is the chance of a blue ticket being the winner? And I'm going to the answer now. So we put 100 on the top because that's the blue tickets. And then 300 on the bottom because that's the total number of tickets. And we multiply by 100. And then we can cross out the zeros. And we get 100 divided by 3, which equals 66.67%. So that is the chance of picking a blue one. So next question. In a different competition, there are gold, silver, and black tickets. There are a total of 250 tickets. The chance of the winning ticket being black is 39%. The chance of it being gold are 43%. What is the chance of it being silver? And I'm going ahead with the answer now. So the answer, the total of all possible results is 100%. So to find the silver ones, we have to minus the gold and the black ones. So we minus 39% for the black and then 43% for the gold. That leaves us with 18%. And notice that we don't need to use the fact that there are 250 tickets. That's just extra information that we don't need. The next question. Be careful with this one. There are 3 runners in a race. One is Karen, one is Rohingya, and the other is Shan. What is the chance of the Karen runner winning? And the answer, which I'm sure you knew, is got absolutely no idea. The winner will be the fastest runner because this is not a random situation. So we won't get a random result. So we can use this idea in reverse as well, the random in reverse. Suppose we want to check if some information is random or not. Maybe it has some other cause even if we don't know that cause right now. We can work out approximately what the data should look like if it was random. Then we check the real data. If they're similar, the data is probably random. If they're completely different, there is some cause and effect happening, even if we don't know what that is yet. Suppose we look at a group of 60 people and recorded which month their birthday was. So if it was random, we could say there would be approximately 5 people in each month. 60 people divided by 12 months. If the data shows around 5 per month, we can conclude that the month in which people are born is random. If we find that January and February are very low and December is very high, we can say it's not random. Then we can start looking for the reason, the cause and effect. Now here is another important idea. The probability cannot be changed by what has happened in the past. So here's the question. Nona Nanu flips a two-sided coin 10 times. 7 times out of the first 10 times, the coin lands on heads. She's about to toss the coin for the 11th time. What is the probability that it will land on heads again? Two ideas that many people have about this situation. Some people know that the chance of heads or tails is 50-50. And when they see that Nona Nanu has flipped it 10 times and 7 were heads, they think if she flips it 10 more times, there would be 7 tails and 3 heads. In other words, the reverse of what happened last time. And that would make the total for the 20 flips 10 heads and 10 tails, or 50-50. Other people look at the 7 heads and 3 tails and think that the 50-50 idea must be wrong. It is clear from the evidence that there will be more heads than tails. So they think if Nona Nanu flipped the coins 10 more times, there would be more heads than tails again. So let's ask the question again. Nona Nanu flips a two-sided coin 10 times. 7 times the coin lands on heads and 3 on tails. If she flips it 10 more times, what will happen? What is your opinion? Who is right? The answer is they are both wrong. The answer is 50% or 50-50. The coin has 2 sides. The chances of it falling on either side is a half or 50%. And the important idea is the probability of what will happen in the future cannot be changed by what has happened in the past. So, example, our country's national lottery increases the prize if nobody wins one week. If the prize is 100 million baht this week, but nobody wins this week, next week's prize will be 200 million baht. Question: does it make more sense to buy tickets only in weeks when the previous week no one won? And the answer, yes, because the prize is bigger in those weeks. But the organizers are also using many people's belief that if no one won last week, the chances of winning are better this week. This is not true. Okay, one girl and one boy, students, put a piece of paper with their name on it in a hat. Then the teacher picks one piece of paper from the hat. What is the chance of picking a student? And the answer, 100%. Whichever name she picks will be a student. Okay, next question. What is the chance of picking the teacher's name? And the answer for that one, 0%, because their name is not in the hat. What is the chance of picking the boy's name? And the answer to that one, 50%. There are two names, so the chance of one of them being picked is 50% or half. Question, what about the girl? What are the chances of her name will be picked? And the answer is also 50% or a half. Every name has an equal chance. If they don't, for example, one student's name is written on a very big piece of paper and the other student's on a very small one, it will not be random and the chances will not be equal. I pick two names out of the hat. What is the chance of picking a girl's name before a boy's name? And the answer is 50%. There are two names, so the chance that the girl's name will be first is 50% or half. After I picked the first student's name out, what about the other student? What are the chances of his or her name being picked? And the answer to that one, 100%, because there's only one name left in the hat. So a question, what if we put three names in the hat? One boy, one girl, and the teacher's name. What is the chance that we pick the boy? And the answer, 33.34%, or 1/3. There are three names, so the chance the first name will be a boy is 33.34%. So 1 divided by 3 times 100 to make a percent equals 33.34, or 1/3. If I pick the boy's name out first, what about the other student? What are the chances of her name being picked next? And the answer to that is 50%. There are only two names left in the hat, the teacher and the girl. Each one has a 50% chance. Conclusions. The chance of your name being picked depends on how many names are in the hat. For any number, the percentage chance is 100% divided by the number of names in the hat. If there's only one name, the chance is 100%. But remember, this only works if the chance of every name is equal. So here's a table that shows a whole lot of chances of success for different numbers in the hat. It's a good idea to memorize some of them because they come up all the time. So if there are two numbers in the hat at the top of the left-hand column, then it's 100 divided by 2. The chance of success is 50%. If there's 3, it's 100 divided by 3, and it's 33.34%. If it's 4, it's 25%. If it's 5, it's 20%. If it's 10, it's 10%. If it's 50, it's 2%. If it's 100, it's 1%. If it's 200, it's half of 1%. Okay, your turn. Again. So Ted bought a ticket in a competition to win a computer. The organizers sold 1,000 tickets for 20 baht each. Normal entered a competition to win a guitar. The organizers sold 200 tickets for 5 baht each. Who had the better chance of winning? The first thing to note is that you don't need some of the information in the questions. It doesn't matter how much the tickets cost. The important thing is how many tickets there are for each person. So Tet, there were 1,000 tickets, so his chance of winning is 1 out of 1,000, or 0.1%. For Nupur, there are 200 tickets, so her chance of winning is 1 out of 200, or 0.5%. So which is bigger, 0.1 or 0.5%? And the answer is 0.5%, so Nupur has a better chance of winning. What if Nupur bought 2 tickets in the competition? Her name would be in the draw 2 times. When she was only in 1 time, the calculation was 1 divided by 200, or 0.5%. If her name is in 2 times, that means she has double the chance of winning. So to calculate this, we change the fraction from 1 by 200 to 2 by 200. With 2 by 200, we can divide the top and the bottom numbers by 2, so it becomes 1 by 100 equals 1%. So we can say, because she bought the second ticket, her chance of winning improved from 0.5 to 1%, or it doubled. So what percentage chance would Nupur have if she bought 10 tickets? And the answer is, when she only bought 1, the calculation was 1 by 200, or 0.5%. When she buys 10 tickets, the number on the top of 1 by 200 changes to 10. So it becomes 10 by 200. Then we multiply by 100 to make a percentage. So we have 10 over 200 times 100. We can cross out the 4 zeros, 2 on the top, 2 on the bottom. So we get 10 by 2, which equals 5 by 1, which equals 5%. Notice that when she had 1 ticket, the chance was 0.5%. When she had 10 tickets, the chance became 5%. We could have taken the 0.5% and moved the decimal point 1 place to the right to multiply by 10 to get 5%. You can do this with probability calculations. If you buy twice as many tickets, you can multiply the original chance by 2. If you buy 3 times as many, you can multiply it by 3, etc. In this example, we multiplied it by 10 because we bought 10 times as many. Now, another important idea. What happens after the name is drawn from the hat is important. Earlier, we did our test with 1 boy, 1 girl, and 1 teacher's name in the hat. We said that at the start, the chance was 1 by 3, or 33.34%, because there were 3 names in the hat. After the first name was picked, there were only 2 names in the hat, and it became a 50% or half chance between the 2 names. That happens because after they take a name from the hat, they don't put it back in for the next draw. Sometimes the organizers don't do it like that. They put the first name back, and the winner of the first time can win a second time. So here's the situation. There are 10 names. They have drawn once. They will now pick the second name. If they don't put the name back, so there's only 9 names, the calculation is 1 over 9. 1 is the number of picks, 9 is the number in the hat, multiplied by 100 to make a percent. So then we have 100 divided by 9, which when you do it on your calculator comes to 11.11%. So that is the chance of winning if they don't put the name back. Your chance of winning the second time is higher than the first time because there's 1 less name in the hat. Okay, if they put the name back, so there are still 10 names, the calculation is 1 number of picks divided by 10, the number of names, times 100 to make a percent. You can cross out 1 0 on the top, 1 0 on the bottom, and you're left with 10%. So you can see if there's 10 names in the hat, the chance is 10%. That is smaller than 11.11% if there are only 9 names. So let's look at this situation. There are 3 boys' names and 3 girls' names in the hat. What is the chance of picking a boy? And the answer, 3 is the number of boys divided by 6, the total number of names, times 100. That's our calculation. So we have 3 over 6, which is half. So 1 times 100 over 2. We can divide the 2 on the bottom into the 100 on the top. So we get 1 on the bottom and 50 on the top. So we're left with 1 times 50, which is 50%. So the chance of picking a boy's name is 50%. What is the chance of picking a girl? And the answer is the same as the boy, because there are 3 girls' names and 3 boys' names. The chances are the same. So we're continuing the same situation. There were 3 boys' names in the hat and 3 girls. They picked the first time and the winner is a girl. They don't put the winner's name back in the hat. When they do the second draw, what is the chance of picking a boy? It's getting a little bit tricky now. So let's go through the answer. So there's 3 boys' names in the hat. So that goes on the top. The total number is 5. So that goes on the bottom. And we multiply by 100. So we have 3 times 100 over 5. We can multiply the top and get 300 over 5. And then we can divide 5 into 300. And the answer is 60. So it's 60%. What is the chance of picking a girl? So I'm going straight into the answer. We'll take it step by step. So first of all, we have 2 girls. So that goes on the top, divided by the total number of names is 5. So that goes on the bottom, multiplied by 100 to make it a percent. So we have 2 times 100 over 5 equals 200 over 5. And we can divide 200 by 5, and the answer is 40. So the chance of picking a girl is 40%. Notice how the boys' chances, 60%, and the girls' chances, 40%, equals 100%, because the total of all the percentages is always 100%. Okay, something a little bit different. Imagine you threw a 6-sided dice. What is the probability of getting number 1? And the answer, the dice has 6 sides, so it can end up with 6 different numbers on top. The chance of getting one of those numbers is 1 out of 6, or 16.67%. Now, we want to calculate the probability of throwing number 1 twice in a row. The first time we have just calculated. It is 1 by 6, or 16.67%. What is the chance the second time? And the answer to that is the chances are the same the second time as the first time, because what has happened in history doesn't affect the possibilities for the future. So there are still 6 possibilities, and the chance of throwing number 1 is still 1 by 6, or 16.67. So the first time is 1 by 6, and the second time is also 1 by 6. How do we know the probability of throwing number 1 the first time and then number 1 again the second time? We need to multiply the fractions. So 1 by 6 for the first one times 1.6 for the second one equals 1 by 36. So we are saying the chance of throwing number 1 the first time and then number 1 the second time are 1 by 36, or 2.78%. Or another way to think about it, it should only happen one time every 36 times you try. Whichever number you choose for the first time, the chance is always 1 by 6. And whichever number you choose for the second one, the chance is always 1 by 6. So whatever numbers you choose for the first and second times, the chances of getting both of them are always 1 by 36. Now, you know the game of snakes and ladders. You have to get from the start to the finish, but in the way there are snakes, if you land on the snake, you go backwards, or there are ladders, if you land on the bottom of the ladder, you go forwards. So here is the situation. You're near the end of the game of snakes and ladders. You have 2 dice and you need 3 to win. Following the logic of the previous slide, you would say the chance of the first dice being what I want is 1 out of 6, and the chance of the second dice is also 1 out of 6. So the chance of both being what I want is 1 by 36. But not quite right. To get 3, you need a 2 and a 1, right? But, and this is important, the order doesn't matter. You can get number 1 first and then number 2, or you can get number 2 first and then number 1. So for your first throw, you have 2 possible successful numbers, number 1 and number 2. What is the chance of throwing a 1 or a 2? So there are 6 possibilities, and you have 2 chances, so the fraction is 2 over 6, or 1 by 3. The second throw, you have to get only one number. If you got number 1 first, you need to get number 2. If you got number 2 first, you need to get 1. But either way, you have only one chance out of 6 for the second throw. So the calculation is 1 by 3 times 1 by 6, which equals 1 by 18. So there's twice the chance compared with when we need the numbers in order. Okay, now I'm going to introduce you to this guy. He's called the brainometer, and he measures how much pain your brain is experiencing. We started with questions at around 1 or 2. And the last few questions were a bit harder, around 5. Now we're going for level 7, and it's getting hard to think. And you need to think, because I'm not going to give you the answer until you've tried it by yourself, because I'm mean. Okay, what about doubles? This is 7 on the brainometer. To finish the snakes and ladders game, you need to throw 12. 2 times 6. Question 1, does the order matter? Question 2, what are the chances of throwing 2 6s? So follow the logic. What is the chance for the first throw? Then what is the chance for the second throw? And then combine them. Okay, now you need 7 to finish. This is 8 on the brainometer scale. What is the probability of throwing 7 with 2 dice? Okay, you need 9 to finish. This is 9 on the brainometer. What is the probability of throwing 9 with 2 dice? So first, ask yourself, if I throw 1 with the first dice, can I still make 9? If I throw 2 with the first dice, can I still make 9? And so on. And then ask yourself about the second dice. And then combine them. And we're going forward now. This is number 10 on the brainometer. This is the highest level on the brainometer. If it goes higher, your brain will explode. Okay, here's the question. You need 9 to finish, but if you get 6, you will go down a snake. What is the probability that you will throw the right number? Okay, take a break. Rest your brain. I'm going to give you the answers now. So it's answer time. How'd your brain feel? Okay, here's the answer for the Brainometer Level 7 question. To finish the Snakes and Ladders game, you need to throw 12, 2 sixes. Question 1, does it matter what order? And the answer is they are the same, so there is no order. Question 2, what are the chances of throwing 2 sixes? So follow the logic. First, what is the chance for the first throw? The answer is 1 by 6. Then second, what is the chance for the second throw? The answer is 1 by 6 again. And 3, combine them. 1 by 6 times 1 by 6 equals 1 by 36. Next one, level 8 on the Brainometer. You need 7 to finish. What is the probability of throwing 7 with 2 dice? So you don't need to calculate all the possible ways, like 1 plus 6 and 3 plus 4 and so on. Just ask yourself, if I throw 1 with the first dice, can I still make 7? If I throw 2 with the first dice, can I still make 7? And so on. And then ask yourself about the second dice, and then combine them. So the answer, it doesn't matter what number I throw with the first dice, I can still get 7. The chances of getting a number that works for the first dice are 100%. Whichever number I throw with the first dice, there's only one number that works with the second dice. So if I throw number 1 first, I need number 6 second. If I throw number 2 first, I need number 5 second, etc. So there's no need to combine, as the chance for the first one is 100%. So the answer to the first dice is 6 out of 6, which becomes 1 out of 1, which equals 1. So we need the answer to the second one only, which is 1 out of 6. So next question, Brainometer number 9. What is the probability of throwing 9 with 2 dice? Ask yourself the same as last time. If I throw 1 with the first dice, can I still make 9? If I throw 2 with the first dice, can I still make 9, etc.? And you'll see not all the numbers work. If you throw 1 or 2, there is no way that you can make 9. So only 4 out of the 6 numbers are okay for the first one. So the chance of getting an okay number with the first dice are 4 out of 6, or 2 out of 3. Then ask yourself about the second dice. Whichever number I throw with the first dice, there is only one number that works with the second dice. For example, if I throw number 3 first, I need to get number 6 second. So the chance of getting the one I need is always 1 by 6. So we combine them. We have 2 by 3 times 1 by 6 equals 2 by 9, which is 1 by 18. And that's your answer for that one. Now, last one. Brainometer number 10. If you need 9 to finish, but you get 6, you will go down a snake. What is the probability you will throw the right number? Ta-da! And the answer is, I hope you didn't waste a lot of time on this one. The answer is the same as Brainometer number 9. The fact that if you throw 6, you might go down a snake doesn't have any effect on your chances of throwing 9. Wow. If you made it all the way to Brainometer number 10 and it's still making sense, you are something special. That's some brain you've got between your ears. But this is the end, my friend. See you next time.